Hello everyone, welcome to my YouTube channel. I am Prabhas and from Sri VENKATESHWARA College of Engineering, studying 3rd SEM in CSC Data Science, USN 1V23 CD038, subject Mathematics 3 for CSC stream, subject code BCS 301, topic Normal Distributions and Applications. In this presentation, we will be discussing about normal distributions and its applications. Here is where your presentation begins. Thank you. Here we will be seeing the contents. First is introduction to normal distributions and characteristics of normal distributions, properties of normal distribution, and at the last applications of normal distribution. Introduction to normal distributions. Definition: the normal distribution, also known as the Gaussian distribution, is continuously probability distribution. It is asymmetric about the mean, creating the characteristics bell curve shape. Parameters: it is defined by two parameters: mean, the average or center point of the distribution. Standard deviation measures the spread data around the mean. Smaller value make the curve narrower and taller, while larger values result in a wider, flatter curve. Probability and area under the curve. The total area under the normal distribution curve equals 1, representing 100% probability. This area helps calculate the likelihood of a random variable falling within a specific range. Here we will discuss about the characteristics of normal distributions. Follows the empirical rule. This rule states that in a normal distribution, approximately 68% of data falls within one standard deviation of the mean. About 95% falls within two standard deviations. Around 99.7% lies within three standard deviations, which which encompasses almost all of the data points. Asymptotic tails. The tails of the normal distribution approach but never actually touch the horizontal line. This asymptotic behavior means that extreme values are possible, though unlikely, as the probability approaches zero but never reaches it. Unimodal distribution. The distribution is unimodal, meaning it has only one peak which occurs at the mean. This single peak represents the almost frequently occurring value in the dataset. Z-scores and standardization. Any normal distribution can be converted into the standard normal distribution, mean of 0 and standard deviation of 1 using Z-scores. This allows for easy comparison of values across different normal distributions. Properties of normal distribution. Shape and symmetry. The curve is perfectly symmetrical around the mean, which means it has equal data points on both sides. This symmetry makes the normal distribution ideal, representing many natural and social phenomena. Mean, median and mode. In a normal distribution, the mean, median and mode are all the same and are located at the center of the distribution. This central tendency is a defining feature of normal curve. Speed controlled by standard deviation. The width of the bell curve is determined by standard deviation. A smaller standard deviation means a narrower, taller curve, while a larger standard deviation results in a wider, flatter curve. Importance in probability. The normal distribution is essential in probability because it enables analysts to estimate probabilities for different events, model uncertainties, and assess risk. It also serves as the basis for inferential statistics, including confidence intervals and hypothesis testing, making it a powerful tool in data analysis. In this slide, we will discuss about the applications of normal distribution, psychometrics and IQ testing, quality control in manufacturing, finance and stock market analysis, natural and social sciences, standardized testing, and the reliability engineering polls and surveys. Psychometrics and IQ testing. IQ scores are standardized to follow a normal distribution with a mean of 100 and a standard deviation of 15, allowing for meaningful comparison between individuals. This distribution helps psychologists interpret scores and characterize individuals into different intelligence level and identify outliers or individuals who may need additional support. Quality control in manufacturing. Manufacturing process often assume that product measurements are normally distributed, which helps establish acceptable quality control limits. By monitoring variation in product measurements, companies can detect deviation from the mean and implement the correct actions to maintain product quality. Finance and stock market analysis. Many financial models, including the capital asset pricing model, assume that asset returns are normally distributed, aiding in the calculation of expected returns and risk. Analysts can use the properties of normal distribution to estimate the probabilities of extreme market movements, which helps in risk management and portfolio optimization. Natural and social sciences. In fields such as psychology, sociology, and biology, many measurable traits are found to be normally distributed, allowing researchers to apply statistical tests to study relationships and trends. The normal distribution enables scientists to draw conclusions about population from sample data, facilitating hypothesis testing and confidence interval estimation. Standardized testing. Standardized tests are designed to yield scores that approximate a normal distribution, making it easier to assess student performance relative to the overall population. The use of z-scores derived from test results allows educators to interpret performance levels, set, set the cutoffs for admissions, and evaluate educational programs' effectiveness. Reliability engineering. The lifespan of the products such as electronics or machinery can often be modeled using a normal distribution, allowing engineers to predict a failure rates and warranty claims. Understanding the normal distribution of the product life helps in designing more reliable products as well as planning maintenance schedules and inventory management. Limitations of normal distribution. Not suitable for skewed data. The normal distribution is symmetric, so it does not accurately model data with skewed distributions, where the data is not evenly spread around the mean. Real-world data such as income or age distribution often exhibit skewness and therefore not well represented by normal distribution. Underestimates probability for extreme values. Fat tails. The normal distribution assumes that extreme events are rare and assigns them very low probability. However, in practice, many real-world phenomena experience more extreme events than the normal distribution predict, making it less reliable in these cases. Assumes independence of observation. Normal distribution model often assume the data points are independent of each other. These can be inaccurate in situations where observations are interdependent or auto, such as time series data where the values are influenced by previous values. The normal distribution is a cornerstone of probability and statistics, serving as a powerful tool for analyzing and interpreting data. Its characteristics bell-shaped curve defined by the mean and standard deviation provides a framework for understanding how data points are likely to be distributed around an average. With its properties such as symmetry, the 68-95-99 rule, and the ability to model real-world phenomena. The normal distribution simplifies calculation and probabilities and enable comparisons across different datasets. In practice, the normal distribution is essential for fields ranging from financial to social sciences, quality control and psychometrics. It facilitates hypothesis testing, confident interval estimation, and the prediction of outcomes by modeling numerous natural and social variables. The normal distribution provides a foundation for informed decision making and supports reliable inferences about population.